Welcome back to Chapter 1, Part 3, Picturing Distributions with Graphs. We're going to continue on with showing how we can organize our data and display it in a meaningful way. So we're going to look at this example, the class makeup on the first day. It's a data table, a frequency table, and also it has the relative frequencies. So this is a relative frequency and frequency table. So on the first day of class, there were 18 freshmen, 10 sophomores, 6 juniors, and 9 seniors, for a total of 43 students on that first day. How we find the relative frequencies, we take the total number of students, and we'll see how many freshmen out of those 43 students. So 18 out of 43 students, so we just do the division and multiply by 100, and that's how we get that percent. So 41.9% were freshmen, 23.3% were sophomore. And again, how did we get the 23.3? We said 10 divided by 43, and we multiplied that number by 100 to give us the percent. So 6 out of 43, that's 14%, and 9 out of the 43 is 29.9%. Now you look and say, hey, how can there be a total of 100.1%? That just means that we have rounding error. Because when we did the 9 divided by 43, it wasn't exactly 20.9%. We rounded. So we'll have a rounding error. If we had have done it perfectly and kept all the decimal places, that would have been 100%. Now that's a table way to display the information. We can also, because this data is categorical, in other words, we're saying what is the grade level of the student that's in the class, it's categorical, we can display it either using a pie chart or a bar graph. So let's take a look at what that would look like. Here's the pie chart for the class makeup on the first day. A good pie chart would have different colors for each of the different categories or variables that you're looking at, or rather variable value. So remember, we could have freshman, sophomore, junior, or senior. 41.9% were freshmen, and this is how we would display it. How you would do a pie chart by hand, we'll talk about that later. This is something that might come up if we used Minitab. Also, a great pie chart has a very good title to let you know what's going on. So instead of saying pie chart, we should say the distribution of the class makeup on the first day. And then having each of those segments where you know what year the student is in, whether it's a freshman, sophomore, junior, or senior, we can tell. So it looks to us that juniors make up the least amount and freshmen make up the most for this first day of class. Now that same information can be presented in a bar graph. Again, it's nicely labeled where you know there's freshmen, sophomore, juniors, and seniors, and what percentage of each of those make up that first day of class. And again, just by looking at the bars, we know that the freshmen are the most, and again, the juniors are the least. The same information, just presented in a little different way, all of which were meaningful and gave us some really good information very quickly just by looking at it. Here we go. Here's another example, the U.S. solid waste. Our variable is what material of solid waste. If we called our random variable X, we would say X is the U.S. solid waste. So one of those values would be food scraps, the other one would be glass, the other one would be metals. So again, we're talking about categorical data, and pie charts and bar graphs are great representations of the material. Now here's a frequency, because it tells the frequency, and the relative frequency chart. So we find out that food scraps, 25.9 million tons, are food scraps. The total weight of U.S. solid waste, see at the bottom the total is 231.9, so we now can find out what percentage of our waste is from food scraps. So I'd say 25.9 divided by 231.9 and multiply that by 100. That's where you get the 11.2%. And you do that for all of them. So we have this wonderful frequency and relative frequency chart. Now let's look what the pie chart would look like. Now again, this shows you how much you can see that paper is our largest waste product. And again, we should have a nicer title than just pie chart. We should say something like the distribution of U.S. solid waste in 2000. And let them know that the waste is in million tons. But we can see here that the smallest is other, so we don't know what's in the other. But we get a good idea of what our waste is. This is the U.S. solid waste, but this now is a different graph. We were looking at the waste. Look at this, it's percent recycled. So this is a little bit different than our pie chart because this is different data. This is for the recycled waste. And we see here that yard waste is our largest recycled waste product in the United States. Paper comes in at not a close second, but a second place. So we've been organizing qualitative data. Now, the first step would be to organize the qualitative data in a table. You can either construct a bar graph or a pie chart. Either one. If you wanted to do both, that's fine also. But either one of those gives very good information. And depending on how you want to display the information, maybe a pie chart would work better than a bar graph. It depends on the situation. Now, here's a reminder that raw qualitative data comes as a list of values. Each value is one out of a set of categories. Allows the researcher to categorize or classify individuals into groups. Now, we talked a little bit about frequency distributions and the relative frequency distribution. A frequency distribution lists each of the categories. So if I was looking at the variable color of your shirt and there were only red, green, yellow, and blue shirts, I'd have a list of 4 different categories. The frequency or count of the observations that belong to each category. So there could be 10 people wearing a red shirt, 11 people wearing a yellow shirt, and so forth. That's saying the frequency at which I see that shirt. A relative frequency distribution, it also lists each of the category. However, it gives the relative frequency or the proportion or percent of the observations out of the total that belong to each of the category. So that's where you take the total. So let's say that there were 10 people in the room, 3 people had shirts. Well, 3 divided by 10, or 30% of the people were in that color shirt. That type of idea. So let's go through a simplistic example, doing it by hand. Very soon I'm going to show you how to do it in Minitab. So I have 8 people in the class, and the variable is what color shirt they're wearing. And I look, and each person, one person had blue, blue, green, red, red, blue, red, and blue. So just by looking at that, you might get an idea that blue is occurs most often, but you'd have to. It's nicer if you have it in a table, then you're not guessing. So we count the number of blues: 1, 2, 3, 4. So my frequency is 4. For the green, there's only 1 that's green, and for red, there's 1, 2, and 3. Now, the most commonly occurring color is easy to see. It's 4. Would be 4. So it was very easy to see that. So the sum of all the frequency, how many different colors there were, how many different people rather, there were 8. Blue had a relative frequency. We saw 4 blue. We saw 1 green, and we saw 3 red. So we could actually write the proportion. That would be a fraction. So we had 4 out of the 8 were blue, 1 out of the 8 green, and 3 out of the 8 were red. But another way we could represent that is in the percents. So I'm going to take 4 divided by 8, get that number, and multiply it by 100. So I take 4 divided by 8 times 100. 4 divided by 8 is 0.5. Multiply that by 100. I'd get my 50%. So I do the same for the green and the red. So I get there were 12.5% that were green and 37.5% that was red. And that's how we do the relative frequency table. In part 4, we're going to continue on with this particular example.